GemDT, we're a UK-based organisation that specialise in bringing together solutions to enable the digital twin. I won't go into the contentious visions of the different definitions of the digital twin, but our digital twin is around capture, monitor and manage. And we see ourselves as a solutions integrator, so we don't develop our own software per se. The engineering hub is in-house developed, but we partner with best-in-breed organisations to assist us in assisting our customers in deploying a digital twin. So very quickly, we go around the complete design, manufacture, support and sustain life cycle. So we have a lot of partners that help us tick boxes in all these areas, and our engineering hub manages and maintains the integrity of the data so it can be used in different work formats. So partners like PTC, Capvidia, obviously, Entopology, Inora, they are the key partners around our offering. And then our engineering hub is managed on the Oracle stack. So the way we manage our data is in a agnostic fashion. So we don't replace unless a customer wants us to an infrastructure. We just complement, but we just make sure the data is in the right place at the right time. Legacy, we have a legacy offering where we can take 2D to 3D data and turn it into something that's usable. We've got a lot of experience in this, and we've got a lot of technologies that we can do it very cost effectively. Reverse engineering, so if you're utilising our blade inspection solutions, you want a golden record if you're a customer, not an OEM. So we have a solution to enable us to reverse engineer very accurately a blade for the golden record. Going on the MBD presentation, this is the blade that the Capvidia will be talking about. So effectively, we have a very fast and accurate way of capturing the data. We can then do all sorts of things with the data once we've got it, managing around tolerancing, looking at areas of interest, and in MRO, whether it's scrap, repair or replace. And then we have technology around, as you'd expect, around inspection, around Polyworks, Geomagic. We're agnostic to the technology you would want, but we can integrate it into our solution. Everything we do is around data, so the digital brain. Very quickly, this is just an example of our engineering hub where you will have a technology, a tablet or whatever, and whatever you're doing around inspection, you can look at the quantities of products you're inspecting, scrappage, you can maintain the throughput of what each individual user is doing. Working with PTC and their ThingWorks, we can do environmental analysis and management. So we offer a dashboard around the digital interpretation of a physical asset. So in this case, if it's a blade, from when it was manufactured through to assembled through to MRO. So it's just an example of where we utilize technology to help our customers know what their products are doing. And the digital brain, again, looking at things like insights, patterns, predictions. We work with Capvidia on the MBD side, so very good in manufacturing. We work with organizations like Inora, where we can guarantee 100% accuracy of data through their algorithm, and utilize technologies like MSET2 and predictive maintenance, because not only will we take data from the actual part, but we will also look at the digital thread. So sensor data, how was a plane flying, or how was a generator producing electricity. We will look at all of the sensor data, make sure it's accurate, so get rid of ones and zeros that shouldn't be there, and then make predictive analysis of that data. That's our high-level architecture. So we use a lot of things like machine learning, AI. It can be on-premise or on cloud, deploying things like augmented and virtual reality, and showing customers what their product is doing. So lots of our clients or prospects are data rich but information poor. That's where we see our engineering hub sitting in the middle. So that's GemDT. I hope that gives you a good idea of where Capvidia fits into our product portfolio and why MBD is so important to the digital twin, both in new and legacy. and I will hand over to Daniel, who is the VP at Capvidia, and he will now and his team do the presentation.
Yeah, thank you, Steve. Yeah, well, thank you everybody for joining. Let me go ahead and present my screen here. So I'm going to give a little bit of background on model-based definition and some of our solutions in the model-based definition area. So, you know, at first, I kind of wanted to give a little bit of background about why one should care about model-based definition, as being more than just a drawing that you can rotate. You know, it's about thinking about semantic data that should be consumed by manufacturing. As kind of the ideal for what model-based definition is all about. So just looking at to the future of manufacturing and how model-based definition will fit into this, I think there are a couple key areas in which one can find some of the value provided by model-based definition. In one lane, we have sort of process and process structure, rigor of process, and automation of process. Flowing downstream from design through manufacture and measure. And then in the other lane, we have data being captured, especially by measurement, and flowing back upstream to design. So in terms of process and automation, what I mean by process is just that, as you incorporate, as we'll see, as you incorporate model-based definition into your process, what it means is that you can take more of an algorithmic approach to what your business processes and what your manufacturing processes are, and sort of remove a lot of the human in the loop element, which leads to a lack of repeatability of process, which is never a good thing. And then from there, it also opens up the door to automation as well. There are various tasks that are done that involve a lot of transcription of data or something like this. That's time consuming, it's expensive, it's by far not the best way to use the valuable resources that you have in terms of your engineers and so forth. So taking advantage of this area is an important part of model-based definition. And we're going to show you a little bit about that, how some of our users use model-based definition to automate some of their first article inspection processes and some of their CMM inspection processes. Now, on the other lane, in terms of data flow back upstream, this is an important area as well. I mean, the current state right now of metrology data, of quality data, is that for the most part, I mean, we're gathering data and we're making pass-fail decisions, and then, for the most part, we archive that data, but it's effectively discarded. There's not a lot of machine learning being thrown at that data, for example. So in general, metrology or quality is not necessarily always viewed as a value-added activity. It's just a necessary thing that must be done so you're not putting out bad parts. But if you think about it, in the age of big data where we are now, it absolutely should not be thought of in that way, because this is the stage of manufacturing where you're gathering incredibly detailed information about what parts are coming off of your production line. And so, understood properly, this should be a tremendous source of value for a manufacturing enterprise. And that's what, this type of structure, providing this type of structure in your data, especially with the quality information framework, which is an MBD format that many of our users use. It provides that framework for being able to provide structure to your manufacturing data and to your measured results data. So those are kind of like the two sort of main areas, the two main benefits, I think, or categories of benefits for model-based definition. So let's get into what we're going to demonstrate right now, what you'll see. We're going to be kind of showing, there are sort of three major steps to what we're going to be looking at. So on the first step, we'll be going over some of the planning aspects of quality, how you can do sort of the the control planning or the ballooning of your characteristics, come up with your high-level measurement plan, and then output first article inspection forms and other types of inspection forms. in a highly automated fashion using model-based definition and using our MBD Vidya software. Next, we'll be showing you a little bit about how model-based definition data could be used by software, inspection software. In this demonstration, we're going to show you Calypso, and how you can really get a jump start on creating your measurement program using model-based definition. And then finally, we'll show you how the results from from your suppliers, results from your CMM measurements, how those all can be harvested using the quality information framework to pull all this data back into our MBD Vidya software and store it in the ISO QIF data format. A little bit more specific about what the workflow is going to be. We started with a native CAD model. It was a Creo model in this case, but any CAD format is okay. From there, we output the data to a QIF derivative model, and we'll see that in the demonstration in a minute. We can view that in MBD Vidya. We apply the ballooning to the characteristics. From there, we'll see the output of an Excel report, which is the the inspection report, a first article inspection report, for example, that would be generated. We'll do a CMM measurement using Calypso, and then finally we'll take the results from these Excel reports and from the Calypso program and pull them back into MBD Vidya into the QIF format. And with that, unless there are any questions, I'd like to pass it along to my colleague Igor, who will show a little bit about this.
Thank you, Daniel. Yeah, so what I'm going to be doing, I'm going to show most of this stuff from the last slide, what Daniel just talked about in a live demo. So because of the time, I would like to start sharing my screen immediately. And what I'd like to start is with our requirement, traditional requirement, which was drawing. Traditional approach to quality would be to balloon the drawing manually and then to go and create a first article inspection and then go manually measure. So what I'm going to be showing here is a native CAD file that we at Capvidia annotated using that drawing. What we can see here are MBD views, or how it's called here, combined states in Creo, that remove need for projections, cross sections on the drawings, and things of that nature. These combined states are there for human readability purposes, so engineer can understand what the requirements on the CAD file are. There's another aspect to this PMI, which we in the industry call, in the jargon, we call it semantics or machine readability. Over here, we can see that if I click on any of these PMI, it will highlight for me which surface it controls and which datum structure to use. All right, without further going into much details of this part, I'm going to switch over to MBD Vidya. MBD Vidya is our standalone application that reads, that's intended to translate package information, analyze, and potentially fix semantics of the PMI. What we can see here that the PMI has preserved combined states, which is important for human readability. And as well, as you can see here, that the semantics are being preserved, at least for association with surfaces. So for instance, if I hover over any of these items, so for instance, this surface finish says 2x, it would show for me, oh, these are the two surfaces. All right. So the first thing that I can do in MBD Vidya, the easiest thing I can do, I can create a bill of characteristics just by clicking on a tool here. And what that would do, it would associate or identify each of the requirements in the CAD model by a number, by a balloon number, and then present the same information in a tabular form over here. And then the tabular form and the graphical forms are linked, so I can go through each of these characteristics. and then see visually where there are, what are they associated with, and things of that nature. From here, one of the easy things to do would be to kind of, if this is a tabular representation, I can export this in a form, in Excel form, and let's see how that looks like. All right, play demo. Might take a little bit to export. All right, looks like it's done. All right, this is how our kind of one of the report formats that we have, standard report formats looks like. As you can see, all the requirements are displayed in this list. They're even linked to these screen captures that each of the requirements can be easily identified what it means. All right. Yeah, this Excel format can be used for manual it's kind of designed for manual inspection. It can kind of have, you can start putting in data, and things like this. So, okay, I'm going to close this, save it, and then maybe demonstrate how the workflow, the manual workflow would look like. So if somebody manually typed in the information, it will show up back in MBD Vidia, and it's fully semantic. MBD Vidia understands what this, what is this associated with. All right, so the next thing I wanted to show is how this QIF format, which we export from the native CAD format, would be interpreted inside the CMM software. This might be more interesting since CMMs are machines who are used to automate inspection. What I'm going to do, I'm going to load the same file in Calypso, in Zeiss Calypso, and see what we have here. I'll take a little bit. All right, so what we have here is a CAD model here, which is typically what, if CMM programmers or engineers, metrology engineers, if they're lucky, they would have a CAD model that matches the drawing. In this case, we have a CAD model, but also what we have here is additional tab in Calypso, which if there's a PMI that's associated, or if the PMI exists in a CAD model, this tab would show up after the CAD import. And what we can see, these are captures for human readability. These are preserved. We have a number of them here. We can query them, understand what the relationships are, understand what are the datums. We can see here that the datum target and the associated surfaces association is maintained and so forth. And all of this is maintained for all of the combined states. And so what we can do with this information, I can quickly pull in this information as far as characteristics and features are concerned, and quickly come up with a kind of skeleton structure for the CMM program. So what just happened on the left, Calypso pulled the information about all the features or anything surfaces on a part that needs measurement in order to get to these characteristics. And these are the characteristics that were pulled in. So this kind of jumpstarts process of CMM programming by defining what needs to be measured, even measurement strategy can be applied. So in this case, the measurement strategy default, what was chosen is to do a scan path along the boundary of the surface. So in other words, first, what needs to be measured is defined, and then what needs to be outputted is also defined, and how to evaluate it. What's left for the CMM programmer is to define how to fixture, which probes to use, and things like this. So I do have this prepared, and I'm going to load the fixture, load the probes, the CMM, a little bit of a tweaked strategy, how to go around the part, define the clearance plane, clearance cube, all of this stuff that is still up to the engineer to do. All right, so this is how fixturing looks like. Let me turn on the CMM simulation. This is how the probe looks like. This is how the CMM looks like. And we can start, what I can do, I can start the measurement. Important thing here is that we had a QI file in, and we're going to have a QI file out as in form of a measurement results. So once this is done, Calypso would produce this QI file, and then I'll be able to demonstrate what it does. So what I'm doing here is running a simulation. This might take a few minutes. Let's see if the last time I ran it, it took about 3 minutes to run. In the meantime, here, what I can show, let's see. What I can show is kind of what would be the time or return of the investment at this stage. So like what I was mentioning is that the CMM programmer, let me see if I can show this side by side. All right. How does this make CMM programmer more productive? So it makes him more productive, him or her more productive in terms of there's no need for manual transcription of 2D dimensions, identifying how to align the part, how to measure it, how to evaluate it, what would be the output. All of this stuff is being automated and defined upstream, which makes so CMM programmer, it's a very valuable resource. Time CMM programmer's time is being used much more productively here. And then these are some of the numbers that was done in partnership with Raytheon. There's some significant, it varies case by case, but they could be some significant time reductions, or CMM programmer could do more programs in a day compared to the old kind of way of doing things. But the advantages don't end there in terms of programming efficiency. As we can see here, once this is done, I'll be able to show how to interpret CMM results. All right, it took 2 minutes. That's interesting. Okay. Let's see. All right, so what I have here is a generated QI file. This is the format or the output of the CMM measurement. And what I'd like to do is import this information back into MBD Vidya. So let me just quickly do a copy. All right, I'm going to copy this information. And what I'm going to do, I'm going to insert this blade measurement number 12. So let's see how it looks like when it's imported. So what MBD Vidya does, it connects these results back to nominals, and it also transforms the coordinate system so it doesn't really matter how this part was set up on a CMM or how it was aligned. MBD Vidya is going to take care of that, of alignment. And what we have here is all the measurements for the blade. As we can see here, these are kind of minute errors here, since this was a simulated measurement. Of course, it's a perfect part. So what we can see here is that all of these results are kind of, we can quickly identify in case there was a non-conformance. We can just click on here, and then that would give us, oh, it's non-conformance here, and then we'll be able to figure out in case of non-conformance what's out, and then that would make the communication, for instance, for a material review board much easier. What else is interesting here to show? Maybe the blade airfoil. This information came through as well. We can see that there's a profile value here, but also what came through is, I don't know if this is visible for everybody, but there are a number of dots here. So what these dots represent is actually a raw data from the CMM. So not only the report made it through, the report is synthetic, this synthetic measurement of what the worst case profile looks like, but also all the individual points came through. And these individual points, as you can see here, that they are offsetted from the surface. That means that kind of gives a hint that this might be a uncompensated raw point cloud that can be then used for whatever an analysis needs to be used for. So that's kind of demonstrating that the requirement is being defined upstream in a native CAD, being correctly interpreted downstream, measured in a correct way, and then there's a pathway for this information to go back to the designer. So therefore maintaining that digital twin or digital thread for this part. What else can I show here? Oh, I can tell here that the surface finish wasn't measured here. Yeah, this would be kind of reserved for a manual measurement. All right, what I can show next is how do we handle more than one measurement? Maybe I can load another QI file that I've did maybe at some other occasion. I can have multiple CMM measurements, as you can see here. There's serial number 1, 2, 3. This is another measurement here. And once that data is in, we can visualize it either by using some sort of visualization technique here, or let me try and load a little bit more of this data. So once we have more data, there's more opportunity to visualize and how do you make sense of that data. You can see here, there's a little chart. So this would be if you wanted to individually import the measurement results, but we can also have handle results in batches. So for instance, if our inspection report was prepared with multiple measurement results, that can be also imported in and then visualized in terms of, oh, okay, so this was the first batch, this was the second batch, or we can have multiple, even more. Let's say I'm going to import this batch too. And then this quickly becomes, oh, we have some non-conformance here. We can then go in here and kind of visualize, okay, so this is supplier number 1 scenario, supplier 2, supplier 3, and then there was a non-conformance here in serial number 5, for instance. What also we can do CPKs. Yeah, since this is simulation, of course, this looks unrealistic, but yeah. So this is pretty much what I had so far to display. So I've showed the maintenance of that digital thread throughout data definition, interpretation, measurement, feeding that information back, and then reporting it in a way that it's easy to understand and easy to analyze further. If there's no questions, or if there's any questions, I'm open to answer any questions. If not, back to you, Daniel.
Yeah, does anybody have any questions about any of that?
I understand this was a fire hose of information. I see there might be some questions in the chat. Let's see. There's a question from Paul. Can you combine parts into assemblies for inspection? It's a good one.
Yeah, there we are doing some work actually with providers of tolerance stack-up analysis tools that do basically that you're saying. Usually what they'll do is they'll simulate assembly and see, with some allowable amount of deviation from nominal in the mating joints of all the tolerances, but still within tolerance, how does the entire thing assemble, when the tolerances stack up? Usually that's done just based on purely simulated data, like just data that's created with the Monte Carlo simulation. But we're doing some work right now with companies that provide some of these tools to feed back data in the quality information framework format, so that they could take real inspection data and feed it into their simulation and do, as manufactured simulation of assembly, and basically do virtual assembly, like you're asking. So I think that's one of the big examples of how this data, which is harvested in QIF and MBD Vidia, how it could be used upstream by design to great benefit. Well, so yeah, I mean, so what we looked at there, we saw native CAD out to the QIF format in MBD Vidia, adding the ballooning or the bubbles to the parts. I'll add all the IDs, characteristic IDs, to each of the items that we're going to measure. We were able to create the inspection forms. We were able to run measurements on metrology software. And finally, we were able to harvest all those results. The idea of usually how we implement this stuff is it's done according to each, the way that each customer's, business workflows work, the way that their manufacturing workflows work. And so, everybody implements this in a slightly different way. We can implement Excel formats that match existing ones that you might use. You surely use Excel formats with your suppliers at least, and probably in internal manufacturing as well. And we can create Excel templates that will output Excel forms that match exactly the formats that you're used to. So it's possible to make this stuff fit in with your existing manufacturing environment. And the guys at GemDT are, well familiar with a lot of this stuff, how it works. So I'd suggest that if you have any questions about that, just talk to them, and they can give you some good advice on how this could fit into your manufacturing. So a couple just anecdotes about some of this, some ROI numbers. Some of the improvements that we've seen in terms of the first article inspection generation. In some ways it seems like a simple thing, but it could be a huge time saver for people. So, for example, one of our aerospace and defense customers here in the US, they did some pilots and found that for some of their complex parts, they were taking 15 to 20 hours for first article inspection generation. That was taken down to 2 in the pilot. And that was just in the pilot, and there's still improvements that could be made there, but we're looking at, almost an order of magnitude improvement. In the consumer goods industry, one of our users is finding 60+% time savings for their PPAP process using MBD for this. And in automotive, where already efficiency is the name of the game and it's hard to find further efficiencies in what they do, they were able to take an 8-week process and turn it into 6 weeks, which for them was pretty hugely significant. So it's a big source of opportunity, this right here. And then as far as measurement goes with CMM, we participated in a publicly funded project here in the U.S., which involved Lockheed and Rolls-Royce and Siemens and some other organizations. And some of the findings were, just in terms of the amount of efficiency and reduced time spent on CMM programming were pretty big. Basically eliminating a large portion of the manual programming side of things. And then we also did some studies on optimization of the measurement using our Pundit software, which I'll talk about in a minute here. And we saw that we were able to reduce the measurement uncertainty of a lot of the default measurements with a popular CMM tool by a factor of 4. So it's just a little bit about some of the ROI that we've been gathering on model-based definition CMM measurements. So in summary, just a quick sort of description of some of the benefits here. Reduced inspection costs, mostly because of reduction of time spent. Faster time to inspection. Inspection is typically a bottleneck, which is a problem that can largely be alleviated with using MBD. Increase in inspection quality. using tools like Pundit, which I'll talk about in a second, and then also just in terms of implementing stricter organizational guidelines on best practices for measurement. Bringing data into the digital thread, like we saw with MBD Vidya. For example, this would come into the idea that Paul brought up having to do with virtual assembly. And then finally, lowering the risk of transcription and interpretation errors, which are a big deal right now. That's a big source of cost, actually, is just simple errors. So yeah, I just wanted to mention the Pundit software a little bit. It's a very specialized software tool to calculate measurement uncertainty for CMM measurements. And so for those of you that are into the field of measuring very tight tolerances with CMM, this could be a very interesting tool. Basically, we take as inputs, what the CAD is, what the geometry of the part is, what is being measured, what is your GD&T, how you're going to be sampling the part, what some of your known manufacturing signatures are, your form errors, and then finally, what type of measurement system are you using? What's your CMM? What's your probe? What's your environment? What's your lab like? And with these parameters, we run a virtual measurement and we'll calculate your measurement uncertainties. This helps you to control your CMM process and make sure that your CMM measurement is adequate for the task at hand. I won't go into much more detail on this. If you have other questions, the GemDT guys are very familiar with this tool, so please reach out to them and they can explain this in a little bit more detail.
Daniel, we do have a question here.
Yeah.
So the question is, what's the training implication for engineers who are used to 2D only for inspection info?
Yeah, it is a little bit of a learning curve in terms of moving to 3D MBD. I think kind of what I think I've found is that it can be a challenge, especially for some of the older engineers that are very experienced and have been doing operating on 2D drawings for 30 plus years. It can be a little bit of a challenge, but conversely, we've also found that that some of the younger engineers coming out of school, they love it and they adapt to it immediately, and it just comes as second nature to them. So it depends a little bit on who the engineer is. There have been studies done by NIST that show that if you have a somewhat intelligent GD&T scheme on your part, it takes actually less time overall to use MBD than it does to take a 2D drawing approach.
Is that, Daniel, is that for the reduced dimension?
Yes, if you take a reduced or either somewhat reduced or very, very reduced dimension approach. In other words, using a lot of geometric tolerances instead of using dimensions everywhere, then it is significantly faster to use model-based definition than it is drawings. That was a study by NIST, and if you'd like more info, I could try to send that to you. So yeah, I'll quickly mention our tool Capvidia. The reason that this is worth mentioning is that in the model-based definition world, you are now driving a lot of your manufacturing based on the model. So what does that mean? It means that your model better be good. And so that's why tools like Capvidia, which do comparative validation, are so important. I mean, so what we're seeing here in this video is we're seeing an assembly, well, two different parts that should represent the same assembly. But what we're seeing is that our analysis showed that in the assembly on the top, there were some components missing based on the component on the assembly on the bottom. So it'll find issues like that where you might expect a derivative model to exactly match its native authority. Or here's another example of a translation that took place, and there are a couple issues that we'll find in this translation of this particular component. Some missing faces in one case, and then some deviation on one of the plane surfaces in the other case. So here's some of the deviation that we're highlighting in that sort of color map view. The couple of uses for this, there are a couple of use cases for this particular tool. One of them is revision control. I have revision 1 of my model and revision 2 of my model, and I have, you know, some notes on what the engineering changes were. But let's check the model now and make sure that those changes, that all of the changes that were done were intentional, because it's not uncommon that you have many unintentional changes made from revision 1 and revision 2, and this could cause a lot of problems. The second use case is derivative model validation. You know, I have my native Creo or my native CATIA, and I've translated a step file. Does my step file actually match my native? Because if it does not, you can have serious problems if you're doing something like measuring based on that step model or machining based on that step model. So those are a couple of the use cases for Capvidia. Yeah, so a question about whether we've done comparison with Foran models. At this moment, we don't work with Foran models, but it's so it's an older file format that is one that we know about. We don't have support for it, but it could be something. It could be one of those that we could implement. From time to time, yeah, you know, certain model types will come up based on customer needs, and as long as they're sort of documented formats, which Foran is, then yeah, we could go ahead and implement that. So it'd be something interesting to talk about, Paul. Yeah, so if there are not any other questions, I would pass it back to Steve.
Cheers, Daniel. So from a GemDT and Capvidia perspective, you know, thank you for the guys from Capvidia. If there are no questions, then what we'll do is we'll just wrap up by hopefully people will understand why we use Capvidia in our digital twin strategy and our digital thread. The key to any digital twin is cost reduction, productivity improvement, cost error reduction, but more importantly, a demonstrable return on investment, which is where Capvidia absolutely ticks all of those boxes. We'll send the video out, a link to the video, so if anybody wants to share it with anybody within the business because it's of interest, we'll send an email out to everybody thanking you for attending, and also put the guys from Capvidia on the emails so that you can get in touch with them if you've got any questions, or if anybody wants to request a piece of demonstration software or a further overview. But we really appreciate you taking your time today to attend this session. And if there are any questions, if people can raise their hands now, if not, we would like to thank you, and we wish you all very well and a safe journey back to your living rooms. Cheers, everyone.
Thank you,
All
Steve.
right. Thank you, everybody.
Cheers. Thank you.
Bye.
Bye-bye.